Welcome to Gas Laws Part 2. So in Gas Laws Part 1, we learned about pressure and all the different units of pressure that we can have. And we also talked a little bit about temperature. So now we are going to apply those into some gas laws. So what are gas laws? Well, gas laws are going to show a mathematical relationship between some different variables. So we're going to discuss how volume, temperature, pressure, and the amount of gas affect each other. So we're going to abbreviate these things in our gas laws and these notes coming up. So we're going to abbreviate volume with a V. We're going to abbreviate temperature with a T. We're going to abbreviate pressure with a P. And we're going to abbreviate amount of gas with one that, unlike the first three, don't make sense. We're going to abbreviate it with an N. P, V, and T are all going to be capital letters, and N is going to be lowercase. So the first relationship that we're going to discuss is Boyle's law, but there are actually 5 different gas laws that we'll discuss over the next couple of days. The first one is Boyle's law, and this is going to show the relationship between pressure and volume. Now, think about it. If I have an amount of gas in a container and I squeeze the container to make it smaller, what happens to the pressure? Hopefully, many of you thought, well, if the volume goes down, the pressure goes up, and you would be right. So what Boyle found was that as his pressure went up, it made the volume go down. And as the pressure goes down, the volume goes up. And this is what we call an inverse relationship. And if this is starting to sound familiar, that's good because you did the FET last week. That hopefully helped out with it. So Boyle's law says that pressure times volume equals a constant. And this constant is just called K. We'll get to it later on in our gas laws. But for right now, we just care about pressure and volume. And because it's an inverse relationship, we're going to multiply them. So this K is a constant for a given sample of gas. It depends only on the mass of the gas and the temperature. And Boyle's law can be used to compare changing conditions for a gas. So initially, we would have P1 and V1, and then we would have P2 and V2 for the final conditions. And we're going to assume that we have the same gas throughout the problem. It's the same amount of gas, and it's the same temperature. We're only worried about pressure and volume. So Boyle's law, if you're looking for the equation, is right here. P1 V1 equals P2 V2. And so this is going to be the equation that we use in our example problems below. So that box that I have around the equation is going to be the most important thing. But in reading these problems, we want to annotate these problems and make sure that we have things labeled correctly. And then it's what I call plug and chug math, where you just plug it into the equation and you use your calculator to chug away and get the answer. So example number 1, we have a sample of oxygen and it has a volume of 150 milliliters. So I'm going to label that volume because it's the first one I'm seeing. I'm going to call it V1. And the pressure is 0.97 atmospheres. And atmospheres, if you remember, are a unit for pressure. So I'm going to call that P. Because it's the first one I'm seeing, I'm going to call it P1. And it wants to know, what will the volume of gas be? So I'm looking for a volume at a pressure of 0.987 atmospheres if the temperature remains constant. Well, that's good because I don't have an equation with temperature in it right now. So I'm going to just take my labeled numbers here and plug them into the equation. So I have 0.947 times 150 equals 0.987 times my volume. So now I want to remember some algebra. How do I solve for volume? And because it's multiplied times the pressure, I would simply divide by that pressure. And what's going to happen is on the left side of the equation, those are going to cancel out, and I'm left with only V. And sorry, that is the right side of the equation, isn't it? And on the left side, I'm going to do in my calculator 0.947 times 150 divided by 0.987. And I get an answer of about 144. But no answer in chemistry is complete without having a unit. So I want to think, what are my units for volume? And because my units for volume in the problem were in milliliters, that's what my units are going to be here. So my answer is 144 milliliters. All right, you felt pretty good with that first example. Maybe you can pause the video here and try example 2 by yourself. But if you want some guidance, I will go ahead and work out the problem as well. So this says a gas has a pressure of 1.26 atmospheres. So that's pressure. Once again, it's the first one I'm seeing, so I'm just going to call it P1. Now, occupies a volume of 7.40 liters. And it says if the gas is compressed to a volume, all right, we've got a second volume here, so we'll call that V2. What will its pressure be? So this time, looks like we're looking for pressure, assuming constant temperature. Once again, that's good, because I don't have an equation with temperature. So I'm going to go back up to this equation up here. So P1 is 1.26 times volume, 7.40, equals P2, that's what I'm looking for, times 9.23. Great. And I'm going to divide by 9.23 on both sides. It's not very clear there. Let me try again. And over here it cancels, and I'm left with just P2. And on the other side, I'm going to do 1.26 times 7.40 divided by 9.23. And I get about 1.01. And my unit for pressure, if I go back to the problem, is atmospheres. So that's going to be my unit here. Now, a good thing to always ask yourself is, does this answer make sense? So you can see my volume got larger, my pressure got smaller. That makes perfect sense. So thank you